Assalamu alaikum class, how are you? As you know that we have started our physics chapter number 5 mechanical properties of matter and cover a lot of its topics. Today we are going to specifically discuss the measurement of atmospheric pressure. You are quite familiar of this term atmospheric pressure because we have detailed discussion in the class. Now let's have a recap of our previous lecture. Like atmospheric pressure, if we define it in simple terms, we can say that the air molecules exert a pressure on the earth, and anything present on the earth is known as the atmospheric pressure. And how can we measure it? How can we say that how much the pressure exerted by the gas molecules on something? So we need some instruments to explain it properly, to give a precise value. So there are a lot of instruments have been invented for atmospheric measurement, but today we are going to discuss specifically any two of them, and the barometer and manometer. So a barometer is basically measure the atmospheric pressure, okay, with the help of the mercury column. And I have highlighted the yellow part that basically define a definition of barometer. Like if we measure the atmospheric pressure with the help of the mercury column, this instrument is known as the barometer. So let's understand its construction. Its construction is too easy and it's easy to use. So I'm gonna show you a simplest diagram of the barometer. Like first of all, what we need a glass tube and we need a glass bowl. Okay, so you need a U-shaped tube and a flat container or a bowl, and fill with the mercury, okay, in the white tube, and the bowl too, that is the u-shaped tube, okay, and that is the container, and both are filled with the mercury, okay. We prefer mercury because mercury is the most common liquid for the barometers and the manometers, just because it is a non-volatile, and volatile means does not evaporate and has a very high density, okay. So the level, there is a scale which is mentioned at the side of the u-shaped tube that help to calculate the exact value of atmospheric pressure. Now how it is work, okay, you have to put that u-shaped tube upside down into the container, okay. When you put the tube into the container, you can see that the level of the mercury will come down, and there is a empty space present in it. So this empty space is known as the vacuum, okay. That is the vacuum. I have mentioned that vacuum is the term describe a thing where there is no air present, okay. You can say that a room in which nothing present in it. So the vacuum is a same term, and you can see that that is the point A. We mentioned it one side point A and one side point B. When you put that tube in the container, you can see that there is no overflow of liquid from its edges. And why it is occur, and what is the scenario behind it? That is the question which can come in your mind. You know that that is the part in which the air molecule exert pressure, and the pressure on both sides are same. That's why there is no overflow and no level decrease and increase occur at 2 points, okay. uh, it means that if we simplify it, we can say that if the air pressure is greater at this point higher, then that will side will come down, okay. And if the pressure is higher at this point, that will side will also come down. If the level of decrease or increment in the liquid level is same, so we can say that the atmospheric pressure is same. Like if we talk about the sea level, okay, like at the sea level, that is the sea level. And I have mentioned that at the sea level, atmospheric pressure is basically 1.013 multiplied 10 raised to power 3 kilopascal. So at that point, both the surface molecules feel the same atmospheric pressure. So there is no change occur at this point. But when we go to the height, and if we are at a mountain like this, uh, that is at a mountain, the level will be decreased. Like we can that is basically mercury. Why we use mercury, I have explained it. And in the previous picture, you can see that the level of mercury in the tube is 760 millimeter. Okay, but when we cover some height, we can see that the mercury level in the tube will fall down. Why? Because the atmospheric pressure goes fall down. And when the atmospheric pressure is decreased, you can see that there is a change occur in the liquid present inside the u-shaped tube. If the pressure is higher, the molecule will come down. Resultantly, the liquid present in it will also come down. Okay, but if the pressure is negligible, like uh, at the height, you can note the difference. At first point, the level was 760 millimeter, and you can see that at this point, the level will start to decrease. Atmospheric pressure start to decrease. That's why the water will flow from that point, and when the water will overflow from the edges, the level of the mercury will fall down. That indicate that the atmospheric pressure is decreased at this point. And if the atmospheric pressure is increased, the level of the mercury will be higher. So that is the working of barometer, and it is quite simple. Let me if we conclude that, we can say if the atmospheric pressure is higher, then the level of the mercury will rise in the tube. And if the atmospheric pressure is lower, the water or the mercury, whatever the liquid you should use in the container, but we prefer always mercury. So the mercury will oval from that as an edges, so the mercury present in the tube will come down, and resultantly the level of mercury will start to decrease. That is the indication of the decrease in atmospheric pressure. So that is the working and the construction of the barometer. And these all lines and these all points are already written in your book, but I just explain it in a simple manner. But still, if you have any query related to its working or its construction, you can ask me. Okay, now let's move to the our next point, which is basically the manometer, that is also used for the measurement of atmospheric pressure. But before discussing its construction and working, let's understand the simple term like how atmospheric pressure indicate as a change in weather. As you know that the atmospheric pressure not always remain same, that is always fluctuate. Fluctuation means the density of air molecules will increase and decrease, because at a sea level the density of the molecule is very high. Density indicate that how much number of molecules present in something. Okay, if you talk about decrease in density, it means less number of molecules are present. uh, so at a highest point, if the density of the at a higher altitude means height, the density of air decrease, and the space is covered by the moisture. And if that's why you can say that there will be a rain. And if it's a cloudy weather, so the density of the air will be less than the normal. Okay, measurement of atmospheric pressure by the manometer. Manometer is very simple for the measurement, a very simple instrument, and it's easy to use. But basically it is used to measure the atmospheric pressure difference, okay, not actual atmospheric pressure. Because in with the help of the manometer we are able to calculate the or to measure the pressure of unknown unknown gas, okay. Unknown gas means we don't know how much the atmospheric pressure of some gas has. So for its actual calculation we can use a manometer, because that's give a reading by comparison. That is the manometer. Manometer consists of the U-shaped tube, and there is always a scale mentioned that in the center. You can calculate the atmospheric pressure by measuring the level, but there is a if it is difficult, you can calculate the reading. You can calculate with the help of the scale that is mentioned inside between these two tubes. You can see that the U-shaped tube has two open ends. When you are placed at sea level, you can say that the level at this point and the level at this point both are same. It means that the air which enter from this point and the air which enter from this point exerting a same pressure on it. That's why the level on both side is same. But if you connect like um sorry. Now you just take a unknown gas and unknown gas cylinder and attach at the one end, and one end is also opened, okay. You can notice that after a few minutes, the level of mercury at this point will start to decrease as compared to this tube level. Why? Just because the air molecule present inside the cylinder will enter at this point and exert a pressure on a mercury. When it exert a pressure on the mercury, that mercury will start to compress, and resultantly the level of the mercury on the other hand on the other side will start to increase. Let's suppose the level at this point is 760 millimeter, and the level that is the 760, and at this point the level is, let's suppose, 38. Now, what is the pressure of this gas? You can measure by comparing the height of this. Like minus the 760 38 from 760, then the value will indicate the actual atmospheric pressure of the gas that is present in the cylinder. So, by comparing the value, by comparing the level of the liquid that is present inside the glass tube, you can explain that the pressure of the unknown gas. But by the use of the barometer you can calculate the value of the actual atmospheric pressure by increasing or decreasing the level of the mercury in the U-shaped tube, like this. So, this level will help you to understand or for the indication of the increase or decrease in the atmospheric pressure. But there is a diagram that is mentioned at the site, that is the Fortin barometer, which is used for in the laboratory for the measurement of atmospheric pressure. Its construction is quite similar to the actual atmospheric pressure, but for the measurement of atmospheric pressure in motor car tires we use a pressure gauge, air pressure gauge. And in the barometer, that is the paragraph which is mentioned at the bottom of the page. Like if we put atmospheric pressure, you just keep in mind that we are talking about the atmospheric pressure at the sea level. This is the value of atmospheric pressure which is always take as a standard and never change on at the sea level. 1.013 multiplied 10 raised to power 5 pascal. Okay, if the pressure at this point like this and the density of mercury is this, then the height, then the height of the mercury column in the tube will be 760 millimeter, and that is the standard. Okay, where there is no increase, where is atmospheric pressure is same and does not fall. That is all about our today lecture. And if you have any query related to that topic and related to that instrument, you can ask me. Okay, I am giving you a home task like write the definition, working, and construction of these instruments on your copies neatly, and draw the diagram and submit your homework within a given time limit. I mean to say, like in a lecture time. Okay, and also I'm going to share this PDF into the group, and that this will help you to highlight all the important points and to understand your topic easily. Thank you so much.